I'm Haider, and I will be the moderator for this workshop for today. I am joined with Dr. Javier Perez. Javier Perez is one of the founders of our company Avanzare and has been working since 2004 in this company. And today he will be holding this workshop of antistatic electrical conductivity in polymers. So I would like to give the floor for Dr. Javier Perez to start this workshop.
Okay, Boyan, thank you very much to everyone to assist to the webinar. My goal after this hour is try to teach or if we, or learn about a bit more about the antistatic and the conductive polymer. First, I would like to make a general overview of the electrical conductivity. And of course, if you need more info, we can have an extra seminar, or even we can profundize in a call or whatever. Please, for questions, if you have any questions, you can send to the moderator, Boyan, that is going to receive all the questions. You can send by the chat as soon as the chat is working, and at the end of this webinar, we can reply to a selection of these questions. First, we are divide the webinar in the following topic. At the beginning, we are going to talk about what is the static charge and how it's generated. And after that, we focus on the conductivity of the material. How is the relation between the different conditions of the conductivity, how we make a volumetric conductivity, how we make a superficial conductivity, how we increase the conductivity in the polymers, and after that we are going to talk about the additive in general that we have to get this behavior in the plastic, for example. First, we are going to show what is the static charge or how it's generated. At the beginning, everyone is formed by atoms in your body, in the earth. There are hundreds of, okay, everything is formed by the atoms. And there are atoms that has the capability to donor or take electrons. It means that at the end, you were generated some atoms with extra of electron and some the other atoms with a deficit of this electron. The electrical charge always is generated by subtraction of the material, and everyone for now, which is the electrical discharge, everyone has suffered electrical discharge. For example, when take a methyl, or when go to a petrol station and take the door of his car and appear the spark. Okay, when we put in contact two material with friction, we are generating the processes to improve the static charge in the material. Okay. The importance of this system is crucial. For example, okay, it's not so important, like for example, in the real in your standard life, no, because if you take a discharge, okay, it's not good, but it is not very dangerous. But in industrial application, the importance of this is crucial. Why? Imagine that you can, for example, generate an explosion, or even you can destroy the electronic components, but generate on the spark. In this video, we are going to see something that, okay, is not common, but it's possible, okay? It is something that happened, for example, for a couple of, for this guy and his wife, he's going to fill in the gas in his car, and the lady has a good pullover, and with the interaction with the car appear a discharge. Discharge go to a material that can be inflamed, and at the end appear the fire. Okay, this is more dangerous than the case that appear only the spark in your hands. Okay, why we are generating the static charge? There are different kind of material that can generate this static charge. Okay, there are material that has the capability to take or to donate electrons more or less easy. There are material like, for example, like positive or negative that can or lend or lose the electron very easy. For example, some material some typical material is quartz of silica that can generate a positive part very easy. And if we join, for example, with polyester, that is a material that is the contrary, at the end you can have a big problems. Okay. One important point is that for example, in your body, when you are generating the star, your body is able to detect this spark or this charge when you take a voltage over 3.5 kilovolts. 3.5 kilovolts is not too much. If you, for example, take a friction with a wall, with a pullover wall, with a material, if you take the friction for several seconds, at the end you have this voltage and can appear the discharge. The conductivity, okay. In this case, we have talked about how are generating the static over the surface over a material. Okay. The other point is how we can diffuminate or transfer this energy through this element. Okay. This is relationship with the capability to move the electricity in the material. It is the word that everybody knows, like conductivity. The material with high conductivity, of course, is less complicated, or is more complicated than accumulating charge, because they can move the charge through the material without problem. I like to compare the conductivity or the problem with the electricity like a funnel. Okay, if we take the sample of a funnel, we can filling with water, that it is for example, the process of generating the static, and the other part is the whole of the funnel. If the whole of the funnel is big, is more complicated to full the funnel. If the hole is very small, it's more easy. Okay. At the end is a joint between the two parameters: the capability to generate the stars, the charge, and the capability to move the charge in the material. The people to analyze how conductor is a material, or how is easy to transmit the electricity in a material, the people talk about two words: or resistivity or conductivity. The two words is complementary, because at the end the resistivity is the inverse of the conductivity. The resistivity, the typical measurement is in ohms. Okay, ohms per meter, or ohms in general. The people talk about ohms resistivity, and in conductivity the people talk about Siemens per meter, or Siemens whatever whatever distance, but all talking in Siemens. Okay, higher resistivity generate lowers the capability to move or to carry the current is lower, of course. For the reason, material with high resistivity can generate more problems. In the following slide, for example, we are going to see different raw material and the capability to move the charge. Okay, that is relationship with the conductivity. For example, we have the material that are considered like conductor, like for example the copper. Everyone knows that the people use copper in your house for the transmission of the electricity. The graphene is too. The resistivity of this material is 10 to minus 8. Okay, it's a very low resistivity. It means that has a very high conductivity. On the other case, there are materials with very high resistivity to the pass of the electricity. In this case, for example, Teflon or material like this. This kind of polymer, for example, has a resistivity 10 to 23. No, not minus, 10 to 23. It means that, for example, from the copper to the Teflon, there are 23 plus 8 unit in this case. If we go to, for example, to the funnel example, the whole of this funnel. In this case, in one case, for example, in the case of the Teflon, will be some nanometers. Some nanometers, very small parts, and it will go, for example, to a graphene or to copper or this kind of metal. The diameter of this hole must be thousands of kilometers. Imagine the difference. But it is the reality to be in context this point. Okay. There are in the last decades the most of the material that the humans has produced, rubber, plastic, composite, are insulated. This action has provoked that the wall has generated that some strong problems in the wall due this problem. For example, has been reported some illness relationship with the accumulation of the static. That, for example, in house or in some buildings, the name of this illness sometimes is the muscular dystrophy. Now we are going to talk about regulation and how make the measurement. That it is a very important point. Okay, we must understand that there are really hundred of static or regulation to make the conductivity. To make the real conductivity. Okay, I selected 3 or 4 that it is the more common, but there are 100. All of them has some point some points appear some points in the regulation. Okay, the first point that it is very important is that we need to stabilize the sample. It means that we cannot make the measurement in one condition. No, we need to put the sample in one condition, in some determined condition for some times. For example, the typical is 4 days at 23 degrees and 50% humidity. And after that, we take the sample and make the measurement. It is important, and okay, it is very important, and later we are going to show why. Okay. Another important point is that the people talk about superficial conductivity or volumetric resistivity. The idea is that see the difference. Okay. In this on this slide, we are going to talk about superficial resistivity. Okay, or superficial conductivity. At the end is the contrary. Okay. For make a measurement of this, we need we have here the sample, and we are going to make the test in the same phase, okay, in the same layer of the material. For make a measurement, we need at least 2 electrodes that would put in contact with the sample and generate a voltage between these electrodes. The idea is to analyze how is the loss in voltage in this sample. For example, in this case, this is the electrode, and we are going to generate a delta in voltage that can vary, can change in function of the regulation. But the standard for antistatic is 100 volts. Okay. One important point is the electrode, or which is the best electrode to make the measurement. Okay, there are at least 4 or 6 different electrodes that we can use. Okay. The typical or the more common is, for example, this one. This one is we must, for superficial, is very good. That the idea is that we paint the superficial of the plastic with 2 silver paints separated by, for example, 1 centimeter. And the side of the electrode is 1 centimeter. If we take a measurement from here to here, we can say a conductivity of superficial conductivity of this material. Another kind of electrode is this circle that we put in contact the outside circle and the inside circle. The difference of voltage is done in these 2 crocodiles. Okay, this is typical. There are other material that it is more complicated to make the measurement. For example, this is a wheel, and in this wheel to make a real conductivity is more complicated. Here we can see, for example, something that we can do, that it is, for example, with silver base, that we can paint two separate electrodes by 1 centimeter, more or less, and the length of this electrode will be 1 centimeter. The resistivity, the surface resistivity value is the value that we get in the machine, multiplied per the length of the electrodes, and divide between the distance between the electrodes. If it is 1 centimeter and this is 1 centimeter, at the end, the direct conductivity talking ohms per square. On the right, we can see a typical conductimeter or ohmiometer, that it is another name that has this kind of material, that make this, but with a direct contact. In this case, at the back of the system, we have two electrodes done by metal, separated by the same distance that the side of the electrode. In this case, with this machine, we can make the measurement in superficial, and you directly get the ohms square. This is the same sample that previously, but it is the connection between the real connection that in this case we must to do, that it is the connection between the surface of the wheel and the interior of the wheel. Why? Because, for example, imagine that you are going to put this wheel in a carriage, and at the end you need to discharge the electricity generated in the carriage with the ground. For the reason, the connection between here to here is the thing that we need to make the measurement. If we focus on volumetric resistivity, that it is another method to make the measurement, in this case, we need to put the electrode connected in two different in the two part of the sample. At the contrary, I mean, because we are going to make the measurement, the resistivity, through the sample, okay? And the voltage will be from here to here, okay? The voltage is called different. In some application is very important because, for example, here we can see the most typical that is in safety shoes. In safety shoes, for example, this is the typical measurement that we need to put in contact your body, your feet, and the ground of the tile of the flooring that you are in which you are step. In this case, we simulate this with a steel piece of steel that is generate the flooring, and the body is simulated by a weight of steel or ball steel, and that we put in contact. And the measurement must be done between here to here. In the following in the following slides, we are going to make how we can make some measurement in-house, not 100% perfect, but give us an idea about how we can make the solution. The first one, we are going to use a instrument like this, the ohmiometer, and we are going to see how it is very easy. Okay, if you have this much the material in our house, you can make this measurement very easy. In this case, this kind of system show conductivity or resistivity in a range. It means talk about not exactly number, talk about 10 to 5, 11, 10, 11 to 5, 10, 11 to 7, 10, 11 to 9 ohms, that it is a range. One important thing is that I forgot to remark that previously to that, this analysis is better to put the system in a controlled atmosphere. For example, 23 degrees and 50% humidity, that it is quite similar for at least 2 or 3 days. Okay. Okay, this is the standard, but okay, we are going to pass to this. This is another more professional method, but at the end we can do at home. That it is paint, for example, electrode with silver. In this case, we have silver paint that it is very easy to buy in whatever shop, and you paint the two electrodes between in the sample. We are going to paint the black one and the white one, and we match to white to dry the silver over the surface, and when we make this, we make the same measurement with a machine in which we can analyze. In this case, we are putting in contact these two electrodes, and the machine show that the conductivity at 100 volt, that I don't, I see that it is not very clear, appear like overload. Overload in this case, because it is a machine that has limited the conductivity to 10 to 12 ohms. It means that in this case, this sample is a black Smith, has a superficial resistivity higher than 10 to 12 ohms square. Okay. Another similar option is this one, that it is produced by two electrodes, the circuit electrode, and we make the same measurement, in this case with the white sample. In this case, appear a conductivity of 42 megaohms. Don't worry about the numbers, because in the following slide we talk about the numbers. Okay, we are going to pass to the next one. Okay, this is another example with the same, but it is in this case a tile of engineering stone in this case, and we are going to make the measurement and see that the conductivity is in the range of 300 megaohms, and antistatic in this case. And the last one, but not the least, is the how make a volumetric conductivity of a sample. In this case, it's a it's a sheet of EVA foam in this case, and we are going to put, as you see, the ground is connected by this electrode, and and on the other electrode is connected by this red cable. The conductivity in this sample is 160 megaohms. Okay, in some application, for example, in safety shoes, the people talk directly about megaohms, or talk about not megaohms per centimeter or not megaohms per meters. The people talk about ohms in resistivity because, for example, we are analyzing a sample, a specimen, a boot. This boot has the resistivity between the body and the ground is 200 megaohms. Okay, it's 200 megaohms, because at the end the site is designed, and we are talking about this specimen. Okay, if we focus in range of conductivity. Okay, this is the general range that the people use. This is the quite easy to find. Okay, the people in general talk about insulative material when has a resistivity, because the majority talking resistivity in ohms in this case, with a resistivity higher than 10 to 9. It means that if you has a material with 10 to 10, 10 to 11, the material is insulative in terms of conductivity. Okay, if we go to conductive, a material is considered conductive when has a conductivity lower than 10 to 5. But imagine that, for example, when we previously talked about copper was 10 to minus 8. It means outside of the slide, I need 3 or 4 computers more on the left to show the conductivity. And the Teflon is in the other part, in the 23, that it is 12 in this part. Okay. Okay. There are many people that directly talk in megaohms. Megaohms is only okay. It's at the end is a question of name. Okay, 1 megaohm is 1 elevated to 6. Okay, it means that if we are talking about antistatic, 10 to 5 is 0.1 megaohms, and 10 to 9 is 1000 megaohms. For the reason many people talk about directly in megaohms. Okay, inside of this antistatic area, there are at least 1 or 2 areas that the people talk. Okay, for example, there are people that talk about ESD material. ESD material is a material that has a conductivity beta that a standard. It's a range inside of the antistatic, but it is better than in the case of the general antistatic. For example, the typical range for ESD system is between 0.1 megaohms to 35 megaohms. There are people that go to 100. No people. There are regulations that can increase this to, in this case, 100 megaohms, 10 to 8. Okay, but depends too much of the regulation and depends too much of the specimen and how we're looking for. Okay, if you remember, we talk about the importance to put our sample in some condition. I mean, we need to put the material at one temperature and one humidity and one condition. Why? We are going to show why. The typical values that I comment is 4 days at 23 degrees and 50% humidity, but it's not defined by the customer, because okay, the regulation shows something, but depending on the application it can be changed. Okay, but the idea is that so how change for example the resistivity of the same specimen only change, for example, some aspect. For example, here we are going to show how change the resistivity of a system of the same product, the same specimen, at 35 degrees and 7 degrees. And 35 degrees, the resistivity that show this specimen is 9 megaohms, sorry. And at 7 degrees, at low temperature, the resistivity goes to 130. Okay, this is extremely important because it is 2 scales more. Okay, as comment, more temperature, more conductivity. Another parameter is the resistivity. The humidity. The humidity, of course, change the value of the conductivity. In some products more, in other products less, but in all the case, change a bit. Okay. For example, here we can see the change in the resistivity, and for example, at 80% of humidity, the resistivity that we get is in the range of 200 megaohms, and if we reduce the humidity to 30%, it goes to 2000 megaohms. It is extremely important. If we join two aspects, the values can change completely. For example, it happened. For example, if you are working in a factory in Bombay at 40 degrees, high temperature, and humidity around 85%, and you take the measurement, and maybe in this case you can get a conductivity around 8 megaohms, 9 megaohms. Okay, you send the sample to Germany, to the winter Germany, then the temperature is 7 degrees. The sample had been in the outside of your facility for 2 or 3 days, and you are going to make the measurement in Germany at I don't know, 10 degrees because it's inside, or 9 degrees, and I don't know, 30% of humidity. The value that you get must be even outside of the range of conductivity, more than 1000 megaohms. Now we are going to talk about mechanisms and agents to generate antistatic in polymers. Okay, there are mainly 3 different ways to improve the conductivity in the material. The first one is based on migratory additive. This migratory additive is some product that you add to your plastic or to your composite, and at the end is not 100% compatible with your system and migrates over the surface and catch humidity. And with this process, we are going to see how they work. Okay. The other point is the ionic conductor. The ionic conductor is the idea to dissolve a cation or an anion inside of your polymer. At the move of this cation or this anion inside of your polymer, generate the enough conductivity to be in the range of antistatic. And the last one is the percolation system. Percolation system is a electronic conductor. Directly, we move the electron in the sample. Go to the next one. the use of one or the other depends too much on the final use. For example, if you look for something for no permanent or for processing, the people always work with migratory additives. If you are looking for a test atmosphere of very low resistivities, you might go to carbon black or to graphene or application in percolation. And for antistatic system, the people work with most of the people work with colorless system like antistatic system. Okay. The last point that we must to mention it is how is the evolution of this resistivity against the time in function of the type of the additive that you use. For example, if we work with migratory additive, the migratory additive are losing the activity with the pass of the time. Okay, to get a migratory additive with more life than 1 year is complicated. Okay, but this is more or less the limit. I mean that you add the migratory additive to your plastic. After 1 year, you are lose the majority of your conductivity. If we work with ionic conductor, we need a small period to a small period of stabilization, but after this 1 week or something like this, you have a more stable resistivity. The same happens, for example, with graphene or with another black system. Now we are going to talk about each one of these additives. The first one is technology. The first one is the migratory additive. As you see, for example, you are working with, in this case, is polypropylene film, and you are going to add this chupa-chups, this system with the ball and the and the bar, that it is the additive. At the end, this material is not 100% compatible with our system and goes to the surface of the composite plastic or rubber. This material is able to take humidity, and with this humidity is able to reach a conductivity in the range of 10 to 12, 10 to 9. The main advantage of this product is, of course, is colorless. Okay, well, of course not, it's colorless. You need to add a very low addition to get the answer. But unfortunately, you are losing the activity with the pass of the time. It's no permanent. Another disadvantage is they have a highly influenced by the humidity. Imagine that if you use the humidity to get the conductivity, if the material has no humidity, the material doesn't work. Another potential problem that can be appear is, for example, that appear a presence of grease over the surface. It happens sometimes when you add a material and the material migrates too far that appear like a grease over the surface, is like a oil. Okay, this is the potential problem that can be appear with this migratory additive. If we focus on ionic conductor, the ionic conductor, I mentioned it, is a system in which we dissolve the charge, the positive and the negative charge inside of the polymer, and the move of this charge inside of the polymer generate the enough conductivity or enough resistivity to be in the range of antistatic between 10 to 6 to 10 to 10. Okay. This kind of system has good great advantage, like the material is permanent. Okay, the conductivity is permanent. I mean, need in function of the product no low addition, is colorless. Of course, it's non migratory, but has no disadvantage, but has a key point that this kind of technology work very good in polymer that has some polarity. Okay, I mean the polarity is highly influenced in the result. Okay, it means if you have a polymer with high polarity, the result is better than in the other case. This is very used in safety shoes, in packaging, in flooring, in rollers, and of course we have a material in the market for more than 10 years. The key word is polarity is beta. Polarity generate low doses, beta conductivity, etc. The last one, and not the less important, is the generate the conductivity directly by electrical conductor. In this case, we are going to generate a net, because this is a net, inside of the polymer with a conducting system. In this case, this conducting system, the typical is the black carbon or graphene. You need to connect one part to the other with this network. The advantage of this is that it is permanent. You can reach conductivity is very, very low in the sense of kilo ohms, in the sense of even ohms in some case. It's not migratory, but has two characteristics. One is the color of this solution is more or less limited. The majority of them is black. It's complicated to get pure colors. Dark color is possible, but pure color is complicated and requires big amount to get the network, because it is clear. Okay, the use is mainly in conductive system like CATES or something like this. There are a derivative of the use of carbon black that is work with inherent dissipative polymer. An inherent dissipative polymer is a plastic that directly or inherent is antistatic or dissipative. Imagine that you have a plastic or you have a polymer that has the capability to transfer the conductivity from one to the other part very easy. In this case, this kind of system, the idea is to generate the same network that previously, but we are going to generate the network with this plastic, with it inherent dissipative polymer. In this case, the key factor is, of course, is permanent, but is not migratory, is colorless, but we require the enough conductivity or the enough amount of product to generate the network. The range of conductivity of the majority of them is in the range between 10 to 6 to 10 to 10. Which is the main use of this kind of technology? Mainly focus on non-Portland system, polymers in which the use of ionic conductor directly is not possible. Okay, but at the end, it's a percollision system too. This is a resume of the four technologies, and in function of your requirement, you need to go to one or to the other. Graphene or IDP or ionic conductor or migratory additivs is one is not better than the other, depend of your application. Okay, depend of the price, that depend of the color, depend of the unit permanence or not permanence, unit humidity depending or not, the resistance level mark to mass is important to know this info. Now we are going to work about directly additives, in this case mainly Avanzare additives, and their use. Okay. Of course, we are going to talk about all of them. We are not talking about migratory additives because, okay, migratory additives is a material that is present on the market for several years, and I assume that everybody knows about that. Okay, first we are going to talk about ionic conductor, which is the typical use of this system. First, we use in polymers with polar. Polar is the key point, and if it is amorphous, is better. The key factor we see previously, but the use is mainly in rubber. Rubber is one of the objectives. NBR, SBR, EPDN, natural rubber, whatever is possible to work with this technology. Thermoplastic, TPU, PET, polyamide is possible. Even in thermoset, in some thermoset like PU, UPR, like I don't know, even epoxy. Okay. If we focus, for example, in rubber, that is the system more developed for ionic conductor till moment. For example, in the case of Avanzare, we have additive in powder form, in liquid form, valid for NBR, valid for SBR, valid for EPDN, even for food grade application. Everything is possible. Only in function of the rubber, because each rubber has different polarity, need to work with one product or the another. At the end, adjust the formula, everything is possible, but is not there are not only or there is not only a one product that you can add and get the conductivity. No. You need to adjust the formula or you need to adjust the formula or the product in function of your raw rubber. For example, here this is a typical safety shoes product or outsole in this case, formulated with nitrile, with 90% of nitrile, and colorless because it's silica, plasticized, the rest of the components, and using a vanestatic plant root like agent to generate the antistaticity. As you see, for example, this is the conductivity in volumetry because it is 76 that you get, for example, with 2, 4, 6, or 8%. It's possible to get even in the range of 10 to 6, very low 10 to 6, okay? It is typical. It is the most common use. In EPDN, of course, is valid too, but in this case, we work with other products that it is Avanzare SBR EPDN. This is a typical formula with some EPDN and the rest of the components with a big amount of charge. And we use this SBR EPDN and the vulcanization pack in function of the addition. The conductivity at the beginning is more than 50,000 megaohms. 50,000 megaohms means 50 gigaohms or 50 elevate to 12. If I do correctly, yeah, I believe. Okay. If we add 5%, we go to, for example, if we focus on volumetric, we will in the range of 1,000 megaohms. And if you go, for example, to 75, you go lower than 1,000 megaohms. And for example, at these two dosages, the material can be considered antistatic. Okay. I forgot to say that, of course, it is necessary. There are a full grade application for this material. Another material with a high chance to be antistatic or to work with very good with an ionic conductor is the PVC. PVC or PVC mixed with rubber. Mainly soft PVC. In this case, we work with two materials. It is Avanstatic 1050 and Avanstatic 333. That in function of the dosage between 0 to 8%, we can get a conductivity in the range of for example, here we see with 5%, we will be in superficial around 400 megaohms, in volumetric in the range of 100 megaohms. Of course, depends too much of the formula. If you are working here with polar product, the result will be better. If you are working with, for example, plasticized, no polar mineral oil or something like this, we reduce this, we increase the resistivity. Okay. One thermoplastic that work very, very good with this system is the TPU. The TPU is a material that the polarity generate very, very, very good results in ionic conductor. Okay. It's possible to get conductivities in the range of 10 to 6, 10 to 7 very, very easy. But of course, depends too much on the formula. Even there are solutions that can be used in TPU coated fabric, for example, when you that you can dissolve in DMF or in acetone and join to the TPU to produce the coated fabric. Okay, this is possible. But the TPU is very influenced by the polymer, the polarity again. Okay, HTPU is different. It's not the same. Polyester that a polyether is not the same if they use plasticized inside or not. The polyol change, everything affects to the result. For example, here we can see a study with 7 different TPUs from polyester to polyether, and with the same amount of dosage of Avanzare TPU master batch, it is one of the products that we can put on the market for that. We can get conductivities from 32 megaohms, it means 3 elevate to 7, to a resistivity around almost 2000 megaohms. It means that the formula of the recipe that there are in the in the plastic affect too much to the final result. Sorry. This is one of our last product that we have developed, that it is produced for plastic with for thermoplastic with some polarity, not so polar like TPU, but with some polarity that, like for example, PET, like polyamide, like PBT, like this kind of polymer that can or need some of conductivity. For example, the main problem is maybe is the limit. More than 10 to 8, elevate to 8 is very complicated. But for example, here we have a test with a PET, and this is a PETG, but PET in general, that for example, if we add 3%, we get around 4,000 megaohms or 4 elevate to 9. At 4.5%, we get around 1.5 elevate to 9, or at 6%, we go in the range of 8 elevate to 8, that it is 800 megaohms. Another product quite similar, but it is mainly for EVA. But EVA is a material that, of course, is used in many applications, but one of the most important is, for example, in shoes or in injection sample for technical piece, special technical piece. Okay, some of them are vulcanized with peroxide. Okay, this kind of system at the end it's like the main of them is like a foam. It's a present bubble inside because in the system, and we are developing a material that added to the EVA, we can produce a system that can be antistatic. One of the disadvantages of this vinyl acetate, of this EVA is the density. You see the density of the material is very low. It means that the foam is the material at the end is a foam. Is a material with some air inside. The air is insulant. For this reason, it's more complicated. If we talk about ionic conductor and use, for example, in resin, in thermoset, here we have the following two slides. We are going to talk about polyester. Polyester is one of the most used resin that is able to use on the market. Okay, the use is there are hundreds of different use. Okay, but here we are going to present one that it is very interesting, that it is the engineering stone or the synthetic marble. The synthetic marble at the end is a mixture between resin, in this case polyester, and quartz. If you remember, I talked at the beginning of the presentation that these two products are one of the worst material to work with this in terms of static, because both material can charge electricity very easy. Okay, imagine that, for example, this is the typical material that used in the kitchen or your house. Okay, but in the past some airport was built with a flooring of this system, because you can produce this this material. The good thing of this material is that you can produce whatever color, whatever design. Is very easy to work with this, but in flooring is more complicated to the static. Okay, and in the airport, after half year of use, the responsibility, the head of the airport must to change the full flooring of the airport due the claims of the customer, because the spark that we generate was incredible. Now, of course, it's possible to generate a flooring like this. It is a standard flooring with I don't know, it's 30 meters for 10 meters, and there are no problem, not the spark. Okay, this is valid for engineering stone, but in SMIC or BMIC is the same, or gel coat. At the end is polyester and or glass fiber or silica, that it is quite similar. We work with another product that in this case is Avanzare UPR that worked in this application and can generate antistatic SMIC or BMIC without problem. One of the most used thermoset using ionic conductor is the PU. The PU, the reaction between polyol and isocyanate. Okay, in this case, the people make the reaction between the polyol and isocyanate, and it is a material that is very used in, for example, in safety shoes. In the standard safety shoes on the market, is produced with polyurethane. Okay, to get some conductivity in this kind of solution, we got another material, this Avanzare 39, that in range of 1 or 2% over polyol, you can reach conductivities in the range of 10 to 60 megaohms without problems. Another application, for example, is that directly in resin, for example, like antistatic coating, for example, in this factory, or here is a different use that it is anti-dust. Anti-dust behavior means that, for example, the powder due to the static can be attracted to the system. Here is a table in which we paint 4 different lines. These lines is without antistatic, this is without antistatic, this is without, and this is with. The idea is that after 1 month or after 10 weeks, the powder was accumulated in the part without anti-dust. Okay, this is important. Now we are going to talk about inherent dissipative polymer. Okay, only for the clarification, the inherent dissipative polymer is regularly a plastic that present some conductivity. The idea is that we are going to mix this plastic with our raw material, but we must to join and generate the network with the plastic. Okay. In Avanzare, we have 4 different dissipative polymers that in this case is the line Avanzare, that in function of the use, in function of the you need food grade, in function of you need more or less temperature, we can work with one or with the other. Some important point is that the rate of use of this material is high if we compare with a unique conductor. For example, in a unique conductor, dosage between 1, 2, 3, 5% is good. If we are working with the inherent dissipative polymer, we need to at least add 10 or 50%. Okay, because this is important. Because why? Because we need to generate the network. Okay. Go here. We are going to show something. Okay, if we try to generate the network with this dissipative polymer, the difference between this and the electronic conductor, that, for example, like carbon black, that we are going to talk in a few moments, is that this kind of polymer can be straight or can be dispersed in the system. First, I need to clarify that this inherent dissipative polymer must be not 100% compatible with your polymer. Why? Because if it is 100% compatible, never we generate this kind of filaments that it is at the end is the base to generate the network. Okay, how we generate this filament depends too much of different points. Like, for example, temperature. Temperature is too important. The MFI of the raw material. How do you make the dispersion? Is something that it is complicated to say exactly which is because in function of the raw material, everything can change. Okay. For example, here we saw 2 experiments working with inherent dissipative polymer with one of our product that it is Avanzare 232, and focus on temperature or of the material. For example, if we talk about temperature, this is the experiment. For example, if we go, for example, to addition of 20% of Avanzare to add the same HIPS product, in this case, Kumo, we are 20%. Same sample, added 20%, production the injection sample at 210 degrees or 230 degrees. The resistivity that you get in one case or the other change completely, goes to 10 to 9 to 3 to 10 to 8. Why? Because the filament that we are producing change in function of the temperature, because your plastic and the Avanzare at 201 at 210 has some capability to generate the filament, and at 230 has different. For the reason, it's very important to control the temperature. Another important point is the MFI and the raw material. Okay, here, for example, we have three different HIPs, the same that in the previous test, the XDIR 850 and the XDIR 1090. Okay. The idea, for example, is that, for example, if this test was be done at high temperature, 240, 250, is more temperature than here. For example, if you work with Kumo with 12% more or less, you will be in the range of lower than 100 megaohms. If we make it the same with the XDIR, okay, even with 50 it's not possible. But if we have with this XDIR, for example, we need 25% to get less than 12 with the other. It is relationship with the MFI, it is relationship with the temperature, everything affects to this. We need to make some trials with your maturity, the inner dissipative polymer and the raw material to know exactly which is the real product, or the real concentrate, the real formula and the real activity, which is the best recipe to do that. Now we are going to talk about electric conductor, real electric conductor. When we talk about real electric conductor, means that we are going to use materials like carbon black, like graphene, like even copper, because it's possible, that can move the electron from one part to the other. The idea is that we need to, again, generate a network from one part to the other. Never our plastic are going to be, for example, in this polypropylene, never our polypropylene will be conductor. The conduction will be in this way, okay? Through the conductor system. The electron goes from here to here, from the easy way to pass, that it is this one. Because the resistivity that all of the black carbon in this case will be 10 to -4, for example, and the plastic will be, the resistivity will be 10 to 12 or more. Okay, this is important. Generate a good network. The dispersion is critical. In the other case, in the inner dissipative polymer, temperature affects to the how generate the filament. Here, the carbon black or the graphene cannot move his surf, but at the end, if you disperse more, if you discrete more the system, it's more easy to get the contact. Here we are going to talk about the percolation. At the end, when we generate the network, it is a percolation. Here we can see, for example, a typical figure in which we see the three regions that we observe when we work with a percolation system like this. Okay, we talk about resistivity in logarithmic scale. Here is insulate, and here is more conductive. At the beginning, when we are adding some black system or carbon black, for example, the connection between this carbon black is not real. There are no interaction between one part to the other. In this case, the material is insolent. Okay. There are a second region in which the conductivity changes drastically, because this is the point in which the conductivity of the system starts. Okay, in this point, the conductivity goes from the insulin to conductive. Being the range of antistatic is more complicated. And the third region is the when the percolation is done completely and get the final conductivity. Two important points in this graph is the percentage of addition to get the percolation, and the second is which is the lowest resistivity that you get. Okay, if we talk about dispersion, dispersion depends too much of your matrix. For example, in resin, in liquid medium, it's more easy to get the dispersion than in extrusion. Or for the reason, for example, if theoretically you can get generate the network of the percolation in a liquid with 0.5 or less than 1%, the same additive add to plastic, maybe we need 10 times more. Maybe we need to go to 10%. Okay, and this is important. I am going to present two easy percolation system in liquid. That it is something that because this is something that we talk about conductivity, and this is the conductive inks. In a conductive inks that you can serigraphiate or you can print whatever thing, you can get a good conductivity between 10 ohms squared to 100 kilo ohm squared. And the material can be used like for integration in antenna or for produce sensor or whatever. The key point here is that the dispersion in the moment that we are working is liquid and is easy. Okay. If we were or to another industrial application, it is, for example, for the production of Avanzare or pipes. The idea is that we can produce this kind of tanks deal in, for example, polyester, with a good conductivity between one to the other part at a low dosage, with the capability to substitute metals. Okay, even if you work with possibly electroresin, you can produce this for very aggressive atmosphere. Not talking about static, talking about corrosive or talking about this kind of system. Okay, this is a system that can be that on the market for many times. If we talk in terms of thermoplastic, there are two problems. The first problem is to disperse in the plastic. This is the first point. The amount of product that you need to add to get the percolation. But imagine that you have a conductor pellet produced by extrusion. You add, for example, 5% of the graphene in a plastic, and you get a plastic that it is conductor. 10 elevate to 4 ohms conductor system. When we inject the sample and produce the sample injected, sometimes we lose the conductivity, goes to, or make the measurement, the same product, and go to 10 to 8 or 10 to 12. Okay, the problem in this case is that that we have a problem of named like skin effect. The problem with the skin effect is that when you inject the sample in the mold, the temperature of the mold, the speed of the machine, there are many parameters that affect to the process, and at the end appear this kind of it's like we put a skin of pure plastic over the network. Inside the network is perfect, but outside we have a skin that protects the material. And this is a very important point if we work with injection sample. To try to solve this problem, the majority of the producers are working or trying to work some master batch in which inside there are additives that reduce the skin effect and can generate the static effect. Okay, here we are going to show two. One is for standard use, for example, for polyolefin, that it is quite standard. That in which we look for a very low percolation threshold. Okay, 25 looks high, but really is a very low dosage. It means that we are going to add 25% of our master batch to, for example, 75% of our polypropylene, and we get a conductivity between 1 to 100 kiloohms between 1 elevated to 3 to 1 elevated to 5, okay? But it is the limit. It's not possible to reduce more the conductivity. We have another product that is the contrary, need more amount to get the percolation, but the capability to get good conductivity is the real aspect that we look for. Okay, in this case, we can get a conductivity between 1 elevated to 1 to 1 elevated to 2, between 1 ohms to 100 ohms, or 1 elevated to 0 to 1 elevated to 2, sorry. That it is a better scale that in the other case. This material is, for example, we have some sample in EPDN that with very high conductivity working with this system. Now we are going to conclude. We are going to take only 3 minutes to explain about our company. Only 3 minutes. No, not. Don't worry. Okay. Avanzare is a European group that tries to develop material from the industry. We are working with many companies developing new additives and solutions for the industry, trying to obtain a gap for his competitors. It means we try to develop together with the company to produce a better material in the case of our customer. Okay. Our field of activity are focused on automotive, footwear, packaging, but always looking for application of high performance additive in all of this sector. Okay, we work, for example, we focus our activity mainly in antistatic and conductive that you see, but we have another interesting field of work like thermal conductor, that it is another point that we must talk in another webinar. Thermal conductor is the capability to move the heat from one part to the other in the plastic. In this webinar, we talk about electricity, move the electron from one part to the other. In the other, we are going to talk about how move the phonon. The phonon is the element that changes the heat or move the heat, okay? And it is even more complicated than the antistatic, okay? Another important point is the metallic tracer. Metallic tracer is a material that can dope to the plastic or dope to the plastic from some characteristics of the metal. For example, the magnetic detectability that they have. For example, it is used in material in food grade application for example, to see some small piece of this plastic that goes to the food. Okay, okay, we have more, but we invite to everyone to visit our webpage, www.avanzarematerial.com, that to know more about our products. You can see. Now this is the aspect of our one of our new facilities. We are a young company, but with a high impact in the region economy. Our plant is around 10,000 meters square of production plant, but our best facility is our labs that with more than 3.5 thousand of meters square, full equipped laboratories that we can develop a lot of important things. Our team, the team in our lab is mainly chemistry. We have 11 PhD in chemistry. Of course, we have graduate and biology in chemistry, but at the end, we form a team very good between engineers and chemistry that can develop the additive for the market. Okay. And here, only for conclude, this is our presence in the world. You can see, for example, there's some mistakes with the emails, but don't worry. The contact person of country manager that we have a lot of presence in China, in India, of course in Europe, and we are starting in Mexico, US, in that. Okay. We are a small company, but with a presence on the world very good, because we look for a special customer that want to develop the additive. And that's all. Only to say the thank you to assist to this webinar. And I don't know if there are any questions. Boyan, you
All
take
right.
it.
So thank you so much. That was very interesting. We have a lot of questions if
Wow.
we can send the slides. The slides, of course, they are available on request. You can send an email to either the email that is available on the screen, either one of them, the sales at avanzare.es or Javier or J. Perez at avanzare.es or to me, ab@avanzare.es, and we will be happy to send you that. We have got so many questions. We are joined with 100 people, and it's time-wise, it's kind of well, not achievable for us to answer all these questions, but we will take some 5 minutes to answer these questions. One of the questions that we have received from
Boyan, I read in the chat the question. If you want, I can select 3 or 4, and I promise to the rest to reply. If there are any email, I can send you.
Okay, so please go ahead, select the questions.
Okay, first, there are at least 2 or 3 persons that ask about P890, the ionic conductor for the using PIT, asking about how transparent is the PIT at the end of the process. Okay, we lose some transparency, of course, but depends too much of the size of the thickness of your plastic. Imagine that, for example, you are adding around, depending on the conductivity that you want, but for example, for 10 to 9, that you can add 3%. Okay, the material is not 100% soluble in the pit. For this reason, it's not completely transparent. You are going to lose something. How much? Depends on your process, but not too much, to be honest. There are people that talk some question. It's not the idea because someone is asking. It is possible to use it with P. I don't know which is the product. I'm sorry. I asked you by email directly. Another people ask me about the P890, that is liquid or powder. Is powder. It's a powder system that you can introduce in the extruder without any problem. Which is your recommendation for injection molding TPE, SBS, or TPB, sort 60 with resistivity requirement of 20 ohms meters? 20 ohms meter. 20 ohms meter is extremely high conductivity, or extremely high, extremely high conductivity. 20 ohms, the only chance, of course, is black, because it's an extremely conductive system. And maybe you can test with Avanzare 535, but you are going to add maybe 50%, because 20 ohms is too high. Maybe it's a mistake and it's 20 mega ohms, but or 20 kilo ohms, but 20 ohms is very, very, very conductive. It's possible, yes, but at the end, the mystery will be half of our master batch, half of SBAs or whatever, and the price is the second point. There are people that are asking for the presentation. Of course, we are going to send you to all the participants the presentation. Is not a problem. Even I assume that Boyan are going to upload the video now in English, or in a few days in Spanish. No problem. My mail, no problem. Okay, which type of graphene do you supply? Could you please clarify the cost, Rolly? Okay. Graphene. Graphene is only for make for another 2 hours talking, but graphene, under the world of graphene, there are hundreds of different products. Okay, for example, there are the real graphene has between 1 to 6 layers of carbon. This is the graphene that is more real. But on the market, you can find this kind of graphene oxide. That means that over the surface of this graphene, there are some oxygen or some atoms, I mean. There are a lot of graphene, a lot of, graphite exfoliate that name it like graphene. And there are something that it is GRP, that it is graphene nanoplatelets, that it is between, for example, 6 nanometers to 30 nanometers. The cost of everything changed completely. For example, in the case of for example, a good graphene, pure graphene for application in batteries, the price is thousands of euros. But for the GFP, that it is more the typical material that is using in thermoset, all of the things that I put in the presentation will be done with this GRP. The price of the GRP will be more or less in the range of 30 to 40, 45 euros per kilogram, depend on the quantities, depend on the country, etc. Please recommend which Avanstatic for non-polar elastomer like EPDN. Yeah, in the EPDN, the best material to work is the Avanstatic SBR EPDN. But okay, there are some considerations that you need to check in the technical data sheet that I am going to send you.
Okay, this was the last
No,
question.
it's really the guy remarked me that it is 20 ohms meter. Yeah, so okay. Conductive. I am going to send you an email, but look, it's very, very, very conductive. It's possible, but right. It's not cheaper.
So Thank you so much, Javier. This is it. We don't have any more time for more questions. We will make sure to answer some of them by email. And if you have questions as well, you can email us as well. As far for the presentation, we will make sure to send that as well. And we will upload the video to our YouTube channel so that you can look at it again if you want to see anything back. We will organize some more workshops in the coming weeks. So stay tuned on our LinkedIn page, on our website as well. As we will publish everything over there. So thank you so much for today. Thank you, Javier. Thank you for everyone joining from all over the world. We have had more or less 100 people joining us. And until next time, thank you so much, everyone. Hope to see you soon. Goodbye.
Bye-bye.